Hi, welcome back to another video. In this video we're looking at another form of loaded beam and how we go about calculating the reaction, as well as the other nuances that surround these type of loaded beam. Now in this instance we're going to be touching on one that is called multiple loaded beam. So basically multiple. All right, so the multiple loading. All right, all this means is that there is more than one load being carried by a beam. Now in this instance I'm going to sketch one similar to what we did in previous videos. All right, so we say we have a loaded beam there, right? And once we have that loaded beam, we're going to add some forces. So for example, here let's add our supports. So we have R, L, and R right there, and then we're going to add some loads. So we're going to add about 3 on this one here. So we're going to put one here, let's put one here, and we could put one here as well. All right, and we'll add some values to this. So let's go 200 and let's go 300. Yeah, we could go 300 and let's go 100. all right, so it means that the total here is 600 being acted down. So it means that the upward force at RL and RR should be equal, or minimum at least equal to that, to make this system be in equilibrium. So let's see if we can go ahead and produce this one here. But before we do, as you can see, this beam here has loads of 200, 300, and 100 unit. You can call it weight if you want to think about it like that, at intervals as shown there. All right, now I'm going to be doing the calculations for the reaction. All right, and if you have watched any of my other videos, you'll know how we use polar polygon to create shear force diagrams and create bending moment diagram using funicular link polygon. All right, so let's see if we can add some dimensions to these forces so we can do our calculations. All right, so let's see. All right, so the first load is going to be 3 meters. The second load is going to be 6 meter, and then 4 meter, and then let's go 4 meters again. All right, wonderful. All right, so how are we going to do this calculation now? So we're going to go here and we're going to say moments. All right, so we have moments at where? R, L, and this is going to be equal to, and this is how we're going to be doing it. We're going to be multiplying 200. All right, 200 of that force multiplied by 300, and I'm going to put it in brackets so things are a bit clearer. Change the color. Then we're going to take we're going to add that to 300. all right, multiply by how far it is away from RL. So in this case it is 6 plus 3, so that's 9. So that's multiplied by 9. All right, plus this 100 here, multiply by how far is it away from RL there. So we're adding 4 plus 4, that's, well, not 4 here because that's not part of it. So it is 4 plus 6, which is 10, plus 3, that's what? 13. All right, so this is how we're going to go about doing it. And when we do our calculations and we multiply across, so basically when we multiply 200 times 3, we're going to get so you know that's 600. all right, and then we add 300 times 9, and then so on and so forth. In the interest of time, I'm just going to write the total value, which is going to be 4,600. All right. Now, once we have that value, it is now time for us to determine the moments. Let's see if we can do it. Moments at RR. Similar to previous video, we continue, and we're going to say that here is equal to, that is going to be equal to the total distance between the two reaction points RL and RR. In this case, that is equal to 17 multiplied by RR, which is going to be equal to 4,600. All right, again, let's make RR the subject, and we're going to have RR, which is going to be equal to 4,600 divided by the distance between the two reaction points, which is 17, and that will give us a value of when we divide that 4,000, we should get a value of 600, I think so, about 600. All right, now with that, now it means that RR is equal to 6. So when we divide 4,600 by 17, we'll get a value of 270, all right, units. All right, now with that, now we know that RR is equal to 2,700. all right, and we know the total force that is acting down, which is what we do, 600. So we're going to say that RL is equal to total force, so this plus this plus this, so these three values added together, which gives us 600. all right, so it's going to be 600 minus that 2,270, that is, all right, and this will give us a value of 329. all right, so it means that RL is equal to 329. all right, and there you go. all right, now this is another scenario in which we calculate reaction based on the loading, and this one here is, as I said before, is a multiple loading beam, and this is how we go about calculating the reaction.